Hello, welcome to Signals and Systems course. In this session, we will be learning about periodicity of the discrete time domain signals. Discrete time domain signals and continuous time domain signals, as far as the periodicity is concerned, they follow the same rules except at the time period of the discrete signals. Okay, so periodicity of discrete signals. So, what is the formula here? X of n equals to x of n plus or minus k n. Equation wise, both are same. Okay, that means x of t equal to x of t plus or minus kt. That's what actually the periodicity concept in continuous time domain signals. Whereas in the discrete time domain also it follows the same thing, but except at one particular point. And in this case also, the signals must be from minus infinity to plus infinity, but repeated. I mean, there must be a portion of that particular signal that should get repeated. So these 2 points are same, but when we look at the properties of n, that's where we have to little focus should be given on it. Let me see like this. So x of n equals to e power j omega n. I'll assume a kind of a signal. This is a complex signal, and I'll be plotting this signal in the Fourier series or Fourier transform. We'll see that. Okay. So what is time period? X of n plus capital N equals to e power j omega n plus capital N. If I assume that these two are periodic signals, then it will be x of n plus capital N. So e power j omega n equals to e power j omega n into e power j omega capital N, and these two will be cancelled. All right. So therefore, what do we get? E power j omega n equals to 1. This is almost the same procedure that what we have done in the case of continuous time domain. Okay. Both are very similar, but let us expand that now. So if I look at this, e power j omega n equals to e power j theta, which is nothing but cos omega n plus j sine omega n. Okay, so this is equals to 1 plus j0, is it not? 1 plus j0. Then what happens here? Cos omega n equal to 1, which implies, or I can say that this one I will write it down like cos omega n is equals to, how can I understand this? Cos 2 pi k. And where what is the value of k? K equal to 0, 1, 2, 3 and so on. So till this point, if you revise the continuous time domain signals and discrete signals, till this particular point the derivation is same. But beyond this, we have a little different properties for discrete signals. So there is a small point that we have to see. So omega n equal to, okay, omega n equal to how much I should write? Cos 2 pi k. Okay, then k equals to 0, 1, 2, 3 and so on. I cannot take k equals to 0 because k equal to 0 gives me DC component. Okay, so therefore then what is omega n? Omega n equals to 2 pi k, where k equals to 1, 2, 3 and so on. So therefore this n equals to 2 pi by omega into k, into k. So that k equals to 1, 2, 3 n. So actually this is the formula for discrete time domain signal. Okay, time period of the discrete time domain signal. What is the time period in the continuous time domain signal? What is it we have written? 2 pi by omega naught, we have written this. Okay, that means that I have substituted k equals to 1 there. But here I am not substituting k equals to 1 because there is a reason. Let us understand that part also. Okay. Now here, what is this n? Now if you look at a discrete signal, okay, so this is 0, this is 1 and this is 2 and this is 3 and so on. Okay, and this is minus 1 and this could be minus 2. I have taken some signal like this. Okay, so if you look at this, this is x-axis, which is nothing but the time axis. Okay, now look at the n values. Okay, that means that n equal to 0, 1, 2, 3 and so on. That means they are all integers. They are all integers. Okay, you cannot take this small n equals to 1.1 and 3.5, something like minus 1.6 like that, but those rational numbers are valid in the case of continuous time domain but not in the discrete time domain. That's what actually we have seen, isn't it? Now, when I consider again the time period here, n equals to 2 pi by omega into k. Okay, now you look at this. K equals to 1, 2, 3, and so on. All right. Now, what is n here? What is this n? N is integers, is it not? N is definitely integer, capital N. Okay. And what is the k? K must be integer because look at this, k is integer, right? So therefore, n is integer, k is integer, then is it not omega must be in terms of pi? Otherwise, if you take omega is also integer, then what happens? This pi will be left over. So in that case, you don't get n as integer. So compulsory in the discrete time domain, the angular frequency must be in terms of pi. In terms of pi. So that is a rule. Okay. So you cannot take angular frequency as 1, 5, 6, something like that. As you can take, again, I just wanted to correlate these two things here. 2 pi by omega naught, you take it. Okay, I'm not writing omega naught because we cannot fix the k value there because k is varying, so therefore omega should also vary. That's the reason we are not putting any value. We are not putting omega naught. So they don't follow the same formula. But here omega naught. Here omega naught can be 1. So omega naught I can take 1 or 2, 5, 6 like that. But whereas if I call this as a capital omega, then in this case that must be compulsory in terms of pi. Okay, let us take a couple of examples, then we will understand this very clear. I would consider x of n equals to something like 5 cos 3 pi n. Okay, 5 cos 3 pi n. Now what is the time period of this signal? N equals to 2 pi by 5 pi, because omega is nothing but 5 pi into k, into k. Okay, now obviously this pi will be cancelled. Now what are the values of k? K equals to 1, 2, 3 and so on, right? So we have to pick up the smallest k value so that this capital N becomes integer. I repeat, we have to pick up the smallest value of k so that this capital N becomes integer. That means k equals to 1, you substitute. You don't get n integer. You get 2 by 5. K equals to 2, 4 by 5. K equals to 3, 6 by 5, 8 by 5, 10 by 5. So that means what is the minimum value of k? 5. Is it not? So therefore, when you substitute k equals to 5, then you will get n equals to 2. So n equals to 2 is the time period, and that happens at k equals to 5. That means first harmonic exists at k equals to 5. Okay, first harmonic exists at k equals to 5. I'll talk about this harmonics more in DTFS class. Okay, now let's take one more problem here. X of n equals to 3 cos 2n. 3 cos 2n. Now what is the time period of this signal? N equals to 2 pi by omega into k. 2 pi by omega into k. And again you can understand that k equals to 1, 2, 3 and so on. Now k equals to 1, 2, 3 and so on. Now n equals to 2 pi by 2 into k. That is nothing but pi into k. Pi into k. Now the question is, do we have any value of k so that n becomes integer here? Any value of k, right? Don't say k equals to 1 by pi. Not allowed, isn't it? Because we have already fixed k as integer. Okay, k compulsory integer. So I cannot take k as 1 by pi. So I don't have any value so that it becomes integer here. Is it not? I would say that here. Okay, this is equals to pi into k. Okay, I don't have any value here. So therefore, this particular signal is a non-periodic signal. The signal is a non-periodic signal. Okay. On the other hand, x of t equals to 3 cos 2t. Okay. I replaced n with t, but let me put in this way. That's not the way of converting a discrete signal to the continuous signal and continuous signal to the discrete signal. You cannot just replace the small n with small t. No, you need to follow the sampling theorem to convert a continuous time domain signal to the discrete time domain signal, that we will see in due course of time. Okay, so my point is, if I do that, then what is the time period here? Time period equals to 2 pi by 2. That's nothing but pi. So this is correct. So in the case of continuous time domain signals, that's correct. But whereas in the case of discrete time domain signals, we need to follow this as the formula. This is the formula for discrete time domain signal time period. Okay. Now let's take another couple of examples on this. Suppose x of t equals to 5 cos 6 pi n by, let's say, 5 minus 2 sine 7 pi n by, let's say, 11. This is actually a linear combination of two signals. That's what I explained in the continuous time domain also. Now how do you find out the time period of this? The time period equals to n equal to LCM of n1, n2 and so on. This formula you can use, but there is another formula also, that also we have discussed. n1 by n2 equals to m by n, which is equals to rational. Either this is method 1, this is first formula, and whereas this is the second formula. Anything you can use, you will get the same answers. So now how do I do n1? n1 equals to 2 pi by omega into k. So 2 pi by, what is omega value? 6 pi by 5 into k. So now I can cancel this pi and pi, and this is 3 times. So this 5 goes up. So that gives me 5 by 3 into k. Now you just have to ask a question to yourself. What is the minimum value of k so that n becomes integer? So I would get n1 equals to 5. Is it not? Because I substitute k equals to 3. Now what is n2 there? n2 equals to 2 pi by 7 pi by 11. 7 pi by 11 into k. Again I can cancel this pi and pi, and nothing can be cancelled because all are prime numbers. Okay, so 22 by 7. 22 by 7 into k. Okay, so what is the minimum value of k so that n becomes integer? 7. Okay, so that gives me how much? n2 equals to 22. n2 equals to 22. So therefore, what is n1 value that we got? 5. And what is n2 value? 22. Now, as simple as it is, either you take LCM of 5 and 22, because 5 is a prime number and 22 is not a prime number, but if it is any one of them is prime number, then LCM is simply the product of these two. That's a simple. So you get 110. That's a simple way of understanding it. Otherwise, you can also apply the same formula, okay, which we have seen in the continuous time domain also. So what is n1 by n2? n1 by n2 equals to 5 by 22. This is already, rational number. Okay, so which implies 22 n1 equals to 5 n2 equals to n. So therefore, n equals to 22 n1, which is nothing but 22 into 5, 110. That's the answer. So that's the time period of this signal. All these signals we can test using MATLAB. So if you have a MATLAB software, then you can just write a simple code, and then we can see that for every 110 samples, this cycle repeats. So that way we can see that. Let's look at one more example on this. Okay, x of t equals to 6 cos 2 pi n by 3 plus 2 sine 9n by let's say 13. Okay. Now that's what I said in the beginning of this discrete signal, isn't it? So you look at this. Okay, this is cos what? Omega n, is it not? This omega compulsory in terms of pi. Now this is in terms of pi. So therefore this is periodic signal, there is no doubt. But what about here? What about there? Okay, that's not in terms of pi. So therefore this is a non-periodic signal. This is a non-periodic signal. Okay, but whereas this is periodic signal. This is periodic signal. So therefore this x of n resultant is a x of n is non-periodic signal. Okay, x of n is a non-periodic signal. So that's how you can visualize all these things. But this category of the signals are well valid in the case of sinusoidal signals. But otherwise, there are some signals which are not in nature sinusoidal. However, still they are periodic signals. How do I do that? You look at this, x of n equal to minus 1 whole power n. Okay, minus n whole power. There are many ways to do this. Either you can plot it, you understand this. Okay, otherwise you substitute n value and also do it. Let us see both the ways. Okay, now let us plot this signal. This is 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. Now if I substitute x equal to 0 there, what do I get? X equal to 0, n equal to 0 I mean to say. Okay, minus 1 whole power 0, that gives me 1. Okay. Now n equal to 1, minus 1, n equal to 2, 1. So therefore for odd values of n you get minus, even values of n you will get plus. Simple. Okay, now let us plot that. This is 1, right? So at n equals to 1, what do I get? I get minus 1. So minus 1 in the sense downward direction, plus 1, minus 1, plus 1, minus 1, like that. And here, now how do I get at this point? And here minus 1, and here plus 1, here minus 1, like this. So what is the minimum portion of n, or what is the minimum value of n so that my signal gets repeated? Is it not? So therefore, by look at it, if I observe this, I have seen the value at n equal to 0, but the same value I can also see at n equals to 2. Is it not? So therefore, what is the time period? I can easily say n equals to 2, which is same as this. Which is same as this. Okay. How do I get this? You look at it. X of n equals to our formula, x of n plus r minus k capital N. Okay. So now if I substitute n equal to 0 there, okay, then what do I get? X equal to, so you can take only one value. So therefore I can say kn. Is it not? When I substitute n equal to 0. Now if I substitute k equals to, assuming that k equals to 1, and then if I look at the n value, I'm getting the same answer. At whatever the value I have at n equal to 0, the same value I can also see at capital N equals to 2. So therefore, you can also conclude this way that the time period equals to 2. Okay. Right. So, and there is something called like, x of n equals to, okay, minus 1 whole power n plus 3 power n, like this. Okay. Suppose if we have a signal like this, then what is the time period of these signals? So to understand the time period of the signals, you cannot apply the formula. This capital N equals to 2 pi by omega into k. You cannot apply on this. Okay. Why? This particular formula is derived assuming that x of n equals to e power j omega n. But this particular signal is not in that particular format. Either you need to convert this signal into the format or plot this signal. Plot this signal. Okay. How do I plot this? N equal to 2 you substitute, and n equal to 3 you substitute, and you calculate the values. Now, what is the minimum value of n so that you see the same portion? Suppose let us say that x equal to 1, you get some a, and let us say x equal to 3, you are getting at same A and you test at x equal to 6, you should also get A. If that is the case, and you can conclude that the signal is periodic signal with the time period